Good afternoon, pilot teachers, and good afternoon, students. Okay, thank you. Sit down. Our lesson today will actually see us look at more information on folding under the heading on diastrophism. The introduction to that lesson looked at the definition to what diastrophism was, and I also mentioned that there are two parts to the topic on diastrophism. The topics are that of folding and faulting. We are on the topic on folding, and we are looking at what folding is and also the simple types of fold that actually are formed as a result of an important force which contributes to the formation of features. Those different features we looked at yesterday were examples of simple folds. So to start off with what I'd like us to look at, I would like us to do a revision now very quickly on what we have covered on diastrophism and on what we have covered on the simple types of fold. Definition to what diastrophism is from what we have covered. Mason, can you explain to the class what you have understood from the definition of diastrophism?
Diastrophism is the deformation of the Earth's crust through folding and faulting under influence of tectonic forces. Okay, very good. So we're looking at a definition of diastrophism being that of influence of tectonic plate movements, which results then in the folding and faulting of the Earth's crust. The deformation of the Earth's crust under the influence of tectonic forces is to do with diastrophism. There are four examples or four simple examples of folding that we have looked at yesterday. Bill, what are those four simple types of fold that we covered in our lesson yesterday?
The first one is monocline, anticline, syncline, and overturned or overfold.
Okay, good. Those were the simple types of fold that we looked at yesterday. Silo, can you explain what folding is or give a definition to what is folding?
Folding is when layers of sedimentary rocks are compressed at the edges or between tectonic plates when they tend to buckle. Okay, very good.
In folding, note there are no fault lines or there are no cracks. Usually, it is the buckling of the Earth's crust as a result of compressional forces. Catherine, can you explain what are compressional forces? Compressional forces? Dorothy, you're going to help Catherine explain what compressional forces are? No? From the class, anyone think they can or they would like to explain to the class what a compressional force is or what are compressional forces? Thank you, Gideon.
Compressional forces are forces that tend to meet each other.
Okay, they tend to meet or they tend to act towards each other. Very good. That's simple as that. And in simple terms, we can use arrows to indicate or to show that force, compressional force. And it is to do with folding that compressional forces are exerted on a layer of sedimentary rock, resulting then in the buckling of the Earth's crust. The other force we will look at later on when we look at faulting, as well as compressional forces when we look at faulting. So in folding,
compressional forces are exerted on a layer of sedimentary rock, resulting then in the formation of the many features and the 4 examples we have looked at in our lesson yesterday. What or how do you explain the formation of a monocline? Val, first of all, tell us what is a monocline and how do you explain its formation?
A monocline is a gentle bend or flexure with a steep-like form in the horizontal bedded or gently dipping rock strata. It only has one limb.
Okay, very good. We're looking at a feature which has been created as a result of compressional forces on layers of sedimentary rock, creating a feature which has only one limb. The other term that we can also use to describing a limb would be the slope. So a feature with one slope would actually represent a monocline if compressional forces were exerted. Kathy, would you like to explain what an anticline is and the formation of an anticline?
An anticline is an outfold or upfold in the strata of the Earth's crust. The two sides of the limbs of the fold dip into opposite directions away from crystalline or central axis. It's the area of uplift there.
Okay, she's explained that. Yes, in simple terms, we are looking at an uplifted area of which has been created as a result of compressional forces. Ebony, can you explain what a syncline is and how it is formed?
A syncline is a downfold or basin-shaped fold of crustal rocks in which the strata dips inwards towards the central axis. It is formed by compressional forces and has 2 limbs.
Okay, good. In simple terms, we can say the depressed area of a layer of sedimentary rock which has been created as a result of compressional forces exerted. Finally, for an overturned fold, Anita, to explain what it is and how it is formed.
Overturned, a fold in which the beds in one limb have been rotated through more than 90 degrees so that they are now inverted, overturned. Basically, it's just one limb over the other limb.
Okay, so we have whereby one limb is actually forced over the other limb, then what you might end up with is an overturned or an overfold. Asymmetrical fold. Shelley, what is an asymmetrical fold? Francis, are you going to help? What is an asymmetrical fold?
One limb steeper than the other.
Okay, very good. It is a simple fold of which one limb is actually steeper than the other limb. So if we looked at all of that information, that is basically what we have covered on folding yesterday and getting to recognize the different types of fold. Note the important force which is exerted on a layer of sedimentary rock for the formation of folds would be force of compression. And the simple examples that we have looked at would be the 4 which were explained, and as well as that, we also have the asymmetrical fold, of which it is simply whereby one limb is actually steeper than the other limb. You have also the overfold, of which that is already explained. And then we also have what we call the overthrust or the nape, which is also an example of a type of folding, of which what happens is that there is a line of fracture which develops because of the continuous pressure exerted on the layer of sedimentary rock, resulting then in a line of weakness. And that line of weakness then will end up with a fracture being formed, and then one of the limb overrides along the fracture onto the other limb, ending up then with a overthrust or a nape which has been created. Okay, with that is revision of what we have covered. I would like us now to move on to looking at some activities. The activities that we are actually going to do will be mainly construction of diagrams to show the different layers, especially given a photograph, and looking at that photograph if we are able to identify the different layers and how folding has actually taken place to give us those different layers as shown from photographs. The 4 types of fold we have looked at already: the monocline, anticline, syncline, and overturned fold. An explanation of each of those was given by the students who were asked to give explanations for the monocline, the anticline, the syncline, and the overturned or the overfold. We also looked at generally a simple fold and the continuous exerting of compressional forces on that particular layer of rock, what can happen in stages of a simple fold, to an asymmetrical fold, to an overfold, and finally perhaps to an overthrust or a nape. And now we are going to look at, in reality, those features shown as in that photograph that is given. But for each of the photographs, you will be given 2 photographs to actually look at for the activities. And for each of those, you will be given at least 5 minutes. And within that 5 minutes, what I would like you to do are the following. Number 1, you look at this particular photograph, see if you can recognize the different layer or strata as shown on that photograph. Then into your exercise book, you are going to sketch the different strata that you can see. So from the photograph here, you sketch, you draw out what you can see, showing the different strata or the layer. After you have done your sketch, on that same sketch, I'd like you to indicate by using arrows the force which is exerted to have resulted in this particular feature. And finally, use an arrow again to indicate if you can see the type of folds that we have actually worked on already. Identify from your sketch if you can see a monocline, or if you can see an anticline or a syncline or an overturned. Okay, so I'll give you 5 minutes now to work on that. We have 3 lots of activities to work on. That is the first of the activities. After 5 minutes, we will move on to the second activity, and the third activity will be the paragraph writing. Yep, correct, good. Okay, good. That's our 5 minutes up also, and I think most of those students who have finished, they have done the right thing here. So if you look at what you're supposed to do, it's a sketch. So if you look at the sketch, your sketch should look something like this. Okay, you check. Your sketch should look something like that. Okay, and showing the different layer or the strata, the force of compression of which you must have arrows acting or pointing towards each other. The arrows on the side here will show you the force of compression. And number 3, you're supposed to see if you can identify some of the simple folds that we have looked at. Here, have the anticline. Here you have a syncline. There is also one section whereby you have one of the, maybe a limb, which is a little bit steeper than the other limb. It's over here when you are coming across, drawing down and then up. That's where you can identify the asymmetrical fold also. But this is simply what I wanted you to actually work on for the 3 exercises. You double check. That's an important skill in geography, because in geography you will be given photographs, and then from photographs you are supposed to be able to identify features as well. Okay, double check on that. Make your corrections if you have not got it correct. There are 3 things you're supposed to show. Number 1, the strata or the layer sketch. Number 2, the arrows showing us the forces. And number 3, identify from that sketch the feature in terms of the simple folds that you can pick out. Let's look at the second activity. That's the first activity. After you've done your corrections, we move on to the second one. Okay, here's another example of folding again. We do the same thing this time. If you have not got your sketch correct the first time round, see if you can get this one correct. You do the same thing, you sketch, but for your sketch, the red line here, I have put in to divide so that you don't include this side on your sketch. I'd like you to only work from the red line and this side here. So you now sketch what you can see from this side of the diagram, and then I'd like you to indicate the force which is exerted on your sketch for the formation of this type of feature, and I'd like you to also see if you can identify from your sketch what type of fold is shown. Again, I'll give you 5 minutes to work on that. Very good. Again, I think with the first practice, most of the students have got that information completed. We'll check. This is photograph 1 we've done. If we looked at photograph 2, okay, we start from here. A simple sketch would show that feature. Okay, so your feature, when you've done the sketch, would look like this, as shown on the photograph here, showing the layer or the strata. These are the different layers or strata. Someone asked if this is an extrusive feature. It's definitely extrusive. This is a road cutting, the side of a road, of which those features are actually visible. They can be seen because here developments have taken place. The side of the road here area has been cut, making those features very visible. Okay, so your diagram, your sketch would look something like this. That's not all. You include the force, compressional forces, arrows pointing towards each other. And note, from this feature you can identify the anticline. Can you see that? The anticline here? Yeah. From this feature you can identify the anticline. If we continued on to the other side, you can also see the syncline given. But because the cutting, I've put a red mark there to separate this side from that, then you would only be able to identify the feature as an anticline. Double check. We happy and satisfied with those 2 activities, with the sketches and labeling of those features? Okay, we now go on to the activity that I'd like you to also work on for your homework, and it's going to be looking at a case study of folding in Great Britain. And the introduction to that I'll go through. The information from the chart here will be what you will be required to actually complete for your homework. Okay, we move on to diastrophism in Britain. It says there that rocks in almost all parts of Great Britain have been folded at some stage. In southeastern England, the folds are generally simple anticlines and synclines, whereas in Scotland, a fold which is referred to as a recumbent fold and nappes are more common. We already know what a nape is from what we have covered, but we'll need to find out what a recumbent fold is. Where folds occur at the surface, they are eroded and often difficult to recognize. Few valleys are syncline and few mountains are anticline. I do not want you to have the impression that all mountains are anticline and all valleys are syncline. No. Few valleys, as mentioned here, can be identified as synclines and few mountains can be identified as anticlines. Escarpments, from what we have covered in our skill work or skills work, or custas are formed by the erosion of rocks tilted by folding, and these ridges form the usual type of hill found mainly in southeast England. So with that introduction, we now come to looking at a map of England, and from that map it shows us that area of which anticlines and synclines are actually found, and the different types of rocks that are found within that region. And from this particular map then, what I'd like you to do is, using this map, to actually complete filling in the correct words from the list here that will go into those spaces. So what I'd like you to work on now is very quickly copy down the passage, then fill in by putting in the appropriate word from the list. And in order for you to be able to complete filling in the correct word into the missing spaces here, you will make reference to this particular diagram. This diagram here will show you some of those features that are mentioned from the passage here, and using the information from the monitor as well as the chart plus the list here, see if you can put in the correct word into the spaces provided. Okay, I think with that information, I would like you then to complete that for your homework. Come back tomorrow and then we'll go through the correction of the activity. Okay, the activity is simply to make note of the paragraph, and then from that paragraph, you fill in the appropriate words from the list with the help or the aid of the diagram here showing that part of England that we are making reference to, for you to be able to correctly put in the words that should go in those spaces provided. Okay, with that information then, that will bring us to the end of our lesson. So class, if you can now stand up. Okay, to the pilot teachers, our keyword for lesson 45 is anticline. Good afternoon and thank you, class.